Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll continue doing chemistry Regent for June 2019, part B2. In part 2, B2, the first question asks you how draws a structure formula for methanol. So I'm going for the reference sheet. The reference sheet here. Mes means I have only one carbon. Okay, mes means I have one carbon. So here is one carbon. Okay. And L means I'm going for the functional group to know what's L means. L here aldehyde, so it have C double bond O H, so double bond O H, that's for the aldehyde. And now the carbon missing one hydrogen, so C H C double bond O. That's the structure for methanol. Okay, so question 52 through 54. Now I'm going to skip all this stuff. Explain in terms of subatomic particles why atoms of H1, H2, H3 each are electrically neutral. So when I talk about electrically neutral, means the electrons equal to the protons. That's why everything is electrically neutral. Okay. Determine the formal mass for D2O. So I have D, that's 2 times 2.014. I have oxygen 1 times almost 16. So here's the result, 82.4, and that's 16. When I add all of them, that's 20.028. Okay. In from table N, identify tritium. So I'm going first here, table N. I'm looking for tritium. He said table N, tritium. So okay, tritium. I don't know, so I'm going for try to find the symbol for tritium first. Tritium. Again, the name is tritium. Tritium. Can't see tritium. I'm going to table N again. I'm going to write on the right side tritium. I can't see tritium here. I can't see tritium here. Oh, so I have to go. Oh, okay. Tritium is a hydrogen. So I'm looking for the hydrogen. Hydrogen H3 over there. Deuterium, hydrogen 3, it's beta minus. So it's beta decay because of tritium here. Question number 55 through 57. Now they're talking about I have sodium nitrate 85 gram at 23 Celsius are dissolved in 100 gram of water. Convert temperature to Kelvin. So if you're looking for the reference sheet, Kelvin over the Kelvin is Celsius plus 23. Kelvin equal to Celsius plus 273. Okay, so that's the formula I'm going to use. So the Celsius 23 plus 273 is giving me 269 Kelvin. Now, based on table G, determine the additional mass of sodium nitrate to be dissolved and saturated 23, 23 Celsius. So I'm looking for the saturation for sodium nitrate at 23. So I'm looking here, the saturation. So that's the line for sodium nitrate. I need I need at sorry I need at 23 degree. So okay, so in the third one here, so almost almost going to be this intersect. So I can dissolve 90 gram. I have 85, so I have to add 5 grams. I have to add 5 grams. Now state what happens to the boiling point if you dilute with additional 100%. Okay. The solute adding adding solute increasing the boiling point and decreasing the freezing point. Now, so if I remove or dilute, will inverse means decreasing the boiling point and raising the freezing point. Question number 58 through 61 is they talking about you have 200 milliliters sample of carbon dioxide is placed in a scaled rigid cylinder with a movable piston at 296 Kelvin and 101.3 kilopascal. State a change in temperature and change in pressure to behave more like ideal gas. We said increase the temperature, decrease the pressure, decrease the pressure. That's going to make any gas behave like ideally. Now determine the volume of the sample. So if you're looking here in the reference sheet, I'm going to use the combined gas law. Combined gas law. So I'm using T1 V1 over T1 equal to V2 V2 over T2. That's the formula I'm going to use. So now for the first situation, the pressure was 101.3 and the volume was 200 milliliter and the temperature was 296. Now the situation, the temperature is 336 and the pressure was is now 152 and the missing is the volume. From that, the volume should be equal to 336 times 101.3 times 200 divided by 296 times 152. So I'm going to use the calculator now. So here, okay, I'm going to multiply with my cell phone. So 336 times 101.3 times times 200 divided by 296 divided by 152 is going to give me the new volume, which is 151.3 milliliter. So I used the combined gas law. A certain term of frequency and force of collision, what would result from decreasing temperature? Okay, so decreasing temperature, decreasing energy, decreasing energy, decreasing the frequency, decreasing the frequency, decreasing the force of collision. So what's going to happen to the frequency and the force of collision? They are going to decrease. Compare to the mass of 200 milliliter sample to the mass when the cylinder adjusted to the volume 400. Okay, mass, here is a rule. Mass never change. Never change. So the mass always the same. The mass always the same. That's the last question now. Explain in terms of both proton and the neutrons why cobalt 59 and cobalt 60 are isotopes. So cobalt 59 and cobalt 60, the protons are is 2727 because the ID for the metal the element is the proton. So in the neutron that's going to be 32, that's going to be 33. So why they are isotope? Because they have the same proton number, because this is the ID for the element, and different neutrons. Okay, compare the penetration power of beta and gamma ray. The penetration power for beta is going for gamma ray is going to be higher. Gamma ray is higher. Why? Because it's only energy. But beta has a mass, so it's going to face some difficulties through penetration. Now complete the equation. So now this is 60, so the sum here should be 60. 0, 0, so x here, the number on the top is 60 now. The sum for the down should be 27. So 27 equal to 28 plus negative 1. So which element has 28? I'm looking for the reference sheet and going for the periodic table. So it's nickel. So here it's nickel 2860. Okay. The last question. From table and determine the time required from the sum. So I have 80. Now have it. It's going to be 40. Have it 20. Have it 10. So what does it mean? I have 3 T halves. So the total time I must multiply 3 times that you have for cobalt 60. I'm going for the reference sheet to check what is the time for the cobalt 60. Here is cobalt 60 is 5271. So that's 312,815.7183 years. So the answer for the last part is 15 years, 813. That's the end for part B2. Wish you understood and have a good day. Assalamu alaikum wa rahmatullahi wa barakatuh.